Solar Group presents. This was once just a dream of the skies, the freedom of flight, of round-the-world journeys. Yet we've made it happen. But what did it take? Our dreams became our goals. Our concepts turned into our plans. Our ideas have transformed into a roadmap and production technology. And the years ahead are booked out with development and construction, components and materials, model manufacturing and testing. All this marks the progress from dream to result. Join us on this journey. Solar Group presents a new generation of airships. The best way to predict the future is to create it, so let's do so together.
Hey friends, hello everyone. This is Gennady.
Fyodor.
We are at the airfield, and you can probably guess what we're doing here, right now. We're assembling our first unmanned airship, the NOVA-01. By the way, here it is. Right now, it's in the assembly stage, which means the parts are still being put together and the structure is not yet complete. It has been filled with gas to about 70% of its intended capacity. So at this stage, it still looks a bit delicate and not fully pressurized yet, giving it a somewhat fragile appearance. There's just one more gas cylinder left, and once that's in, it'll go from this state to a completely smooth shape. Yesterday there was nothing here, and today, look at it now. In the hangar, we move around barefoot.
Must keep dust out.
The first rule is that it absolutely has to be very clean here. The envelope is extremely delicate, and even a tiny hole in it could easily cause a helium leak. I'll explain everything is set up. I'll tell you how it's put together. Well, you can pretty much see for yourself, right? It's tied down by the nose, and the blimp is held by a net because it's already filled with helium and trying to float up. By the way, it actually looks really interesting, honestly, to tell the truth. Victor here, show you. I wanted to give you a little tour of the blimp. The nose reinforcement actually consists of, in total, 12 duralumin beams, a central flange where all of them are securely attached, and a central one that connects directly to the mooring unit itself. This here is the filling valve through which the helium is supplied. In about an hour, we'll be using this again. We'll be topping up the blimp. Right now, they're installing the lower tailplane. The upper one was just installed. Once the lower tailplane is in place, we'll fill it up to working pressure. This is the flight termination device. It's for emergencies. If all systems fail and the blimp starts drifting away, it can be activated via a separate radio channel. Nothing is installed here yet. Tomorrow, we'll be mounting this system inside. Basically, a signal is sent, the filament burns through the membrane, a calculated amount of helium is released, and the blimp lands safely back down. This is the flexible filling hose. It was needed to increase the internal pressure of the envelope when we were conducting acceptance tests. We were checking the envelope. Normally, this will be screwed in, but a special membrane will be installed here, so it won't be visible. This is what the grommets actually look like, which are specifically used for lacing or securely tying the gondola. Over there, you can see them in place. The speed will be measured by separate modules, a GPS module, a GLONASS module. Basically, it's the smart part of the airship that will help it navigate. And of course, the gondola itself. We'll show and talk about it a bit later.
It's still being assembled.
Yeah, you might have seen it in the office in the video. But here, we haven't put it together yet. We've just started, just set it up, basically. Alright, let's go see what's happening in the back. Or maybe there's something interesting here. Nope, nothing here. Let's not show it.
Here, the guys are assembling the tail section.
If you get in the way, you might hear swear words, so it's better not to.
With these, the airship is starting to look more like a real airship, because without them, it didn't really resemble one. We're going to have 4 of them, right?
Yes. Let's walk around. Here, we have the same kind of tail reinforcement made from 6 beams. This is the tail flange, and the tail rudder with 2 propellers is installed here. Obviously, a rigid airship doesn't have this problem, but since we're just starting out, with a small drone, let me show you how the special pockets are set up. These are the pockets, and here are the wires. They're attached with Velcro with C. It comes off like this and sticks back on. These are middle cables, yes, which are used to tension the tail assembly. These are middle cables, yes, which are used to tension the tail assembly left and right and set it at the correct angle.
Yeah, to give it a fixed, static look.
Sort of. The only thing we haven't mentioned yet is the rear wheel, which will also be braced with cables like these, just like the others. It will be braced to the tail assembly, attached to its front part, and will also be set in its own position. It's needed so that when the airship, for example, takes off, not vertically. Volume of envelope. Inside, it looks kind of like a big callus. It's needed precisely because maybe it's not very noticeable right now, but overall, if you looked from a distance or in a wide shot, you'd see that now, after we closed the door, the cold air stopped blowing on the envelope. It warmed up a bit and smoothed out a little. So, it's a very lively, breathing volume of gas. It basically acts like a living organism. And to release pressure, the inner ballonnet will expand, press against the ballonnet, the valves will open, and let out the excess air from the ballonnet. And then, when the temperature drops and the pressure decreases, the sensors detect the pressure inside the envelope is too low, so the fans turn on. By the way, you can actually see them from here if you try. This is what they look like. Here's the installed fan, and here's the installed valves. The fan will turn on and add pressure when needed. Yes, this way the airship will always maintain the same shape. And this is also a sleeve for emergency air filling of the ballonnets. It also gets rolled up and pressed by a membrane. And it won't be visible. So, today is the second day of assembling our airship. As of now, this is what it looks like. What are our next steps in the assembly? We need to finish assembling the tail unit and secure it completely. We'll also install the steering device. That's right, we need to install the tail unit and fill it with helium. Then there are special, I forgot what they're called, things that we tighten, stretch, and adjust the tension on. We set up the tail unit, and here you can see them. This is what they look like. Russ, what are these called? These ones here. Don't mess, I set it up.
No, we just bolted back in.
Basically, these are used to tighten the cables, making sure everything stays secure and in place. And this part here is inserted into the mechanism to hold it firmly. Just so it's clear, when you listen closely, it actually sounds kind of like a drum being played.
The fabric is very light and pleasant to the touch.
Yeah, then this part here at the back will have the section that's controlled by the servo installed. And here are the small ones. We'll put in 4 of them, then we'll install the servos themselves, also today. And I'll keep working on assembling the gondola.
I just briefly touched on where we are today.
Well, you totally gave it away.
Gave it all away.
Yeah, at first we thought maybe we shouldn't say anything yet. Maybe it's too early. But actually, it's not too early, it's been said.
This is a small private airfield in the Serpukhov district of the Moscow region. It just so happened that we were lucky enough to do our testing and assembly for our project right here.
Yeah, the hangars here are just the right size for us. We fit in perfectly. The administration itself approved these tests for us. There are some ropes here. We'll tie it up with a rope, and our envelope will rise up this much more. That's exactly so that we can calmly install the gondola and then work with the gondola under the airship. So tomorrow it will be higher. Tomorrow it will have the gondola. We'll be installing the electrical and signal systems and bringing it to life.
So like, comment, and share, guys. It's thanks to your support, and ours too, that we're moving this project forward. We're letting more and more people know that this project actually exists, that they can absolutely take part in it, support it, and truly help make airships a part of our skies again.
Yes, let me remind you once again, for those who haven't heard, this airship, the NOVA-01, is a scaled-down version of the airship we're currently building. We're developing it, and in fact, we've already started producing some parts. We're buying parts for it. This is the NOVA-02 airship, seating 6 and with a volume of 2,000 cubic meters. This one is 130 cubic meters. The envelope volume of that one is just over 2,000. And we're also buying equipment for it. Welding equipment for making the envelope, cutting machines, in general, a lot of different things. It will be ready by the end of the year or the beginning of the next. And in order to test the automatic control system, the unmanned system, we decided to make a small-scale version. First of all, to record its dynamic characteristics and test them. For example, here the thrust of the propellers matches the frontal resistance at the same speed, roughly speaking. This way, we'll understand how the NOVA-02 will behave. And that's exactly why we made this small-scale version, so we can fly it and train our drone to control the airship as a whole. We'll experiment with it ourselves and operate it. As they say, the most difficult part of an airship is this one, its operation, specifically the near-ground phase. Near-ground operation, yes. And with this little one, which is a prototype, it will be used as a dedicated test stand for testing and evaluating several key mooring components in detail. The low point. Traditionally, all airships are moored by the reinforced nose, at the nose point.
It's impressive. And really, guys, this is the first time we're seeing an airship, practically our very first one. Even though in the world of airships, this isn't considered a fully fledged, large airship like it's supposed to be, it's still, let's say, the first step towards something bigger.
In just a week, it will become the largest unmanned airship in Russia. By the way. Yeah, and about the 2,000 I wanted to mention. These gates here, I don't remember exactly, maybe they're about 6 meters high, but the other ones are 12, so the gates will be twice as tall, twice as long, and that's just for a small 2,000 cubic meter airship. The next one will be 8,000 and then 35,000. The 35,000 will be considered serious, and that's the smallest of the rigid ones. In general, the minimum possible and strict.
Those are just colossal sizes.
Yeah, but it's worth it.
Absolutely. That's exactly why we're all here working on this. We get a lot of attention from random passers-by. People show up here, see what we're doing, and everyone is really curious and interested in what we're making. They keep asking questions about why we're doing this and how exactly we're making it happen. More and more often, at least in my experience, I run into people who have some misconceptions about airships, thinking they're something old and inefficient. Or, on the other hand, they think it's something fantastical, something unreal for our everyday lives. But that's exactly what we're going to change, people's perceptions.
Yeah, it's pretty interesting. Tired of standing? We can switch to the cameras on the tripod if you want. Anyway, yeah, airships are actually beautiful. The main thing is that they're functional, controllable, and practical. All of this will happen, you know. If 100 years ago they were operated quite successfully, we can handle it too. Besides, we don't really have any other chances or options. By the way, here's the tail thruster. There are electric motors hidden inside here. It'll be installed like this at the tail end. There will be one propeller here and another one here.
By the way, these are the propellers that will be used for the main propulsion. And here they're definitely smaller.
For some reason, they're lying over there. Someone dragged them away, and I didn't get a chance to scold them. But they're in their proper place now. Basically, it's necessary so that when the airship is near the ground and doesn't have any propulsion speed, only the rudders are working. The rudders only work when the airship is moving somewhere or being blown by the wind. That's why you need a tail thruster, so that when the speed is 0, you can still turn and control it somehow.
I think a really good example is when, say, a ship is stationary at sea. If it uses its thrusters to turn, it will just stay in place.
Yeah, exactly.
That's exactly what this special extra thruster device or thing is for.
These here are also the main engines. So, engines of this particular size, as you can see, will in fact be carefully installed on the 130 cubic one, and they'll also serve as the tail thruster for the NOVA-02 spacecraft. Briefly about the difference. I don't remember how many kilowatts, so I won't lie. I didn't bother to load that info into my head.
Well, if you're interested, just let us know and we'll definitely provide that information.
Yeah, I know for sure that at peak power and RPM, they produced between 40 and 45 kilograms of thrust per propeller on the test stand. I don't remember the exact number. So, with 2 propellers, that means we have about 80 to 90 kilograms of thrust, including even the lift force. So, since our beam is rotatable, we can turn them vertically, horizontally, basically parallel to the ground, right, and get an extra 90 kilograms of lift. Basically, it could lift me.
We'll try it. I'm ready.
Yeah, but actually, it's not designed for that kind of load capacity, because the entire load would be distributed by the gondola.
Correct term.
Well, 20 kilograms is the payload.
Payload.
Yeah, that's theoretical. Over there, we have a weight summary.
Yeah, I wanted to transition to that.
Sergey keeps careful track of it. Yeah. We have both large and small scales, you know, just to be clear.
Before installing anything on the envelope, every component has to be weighed. Down to the tiniest little nuts, we weigh everything by the handful and keep records so we can know the total mass of the whole apparatus.
Yeah, we haven't recalculated the total mass yet. Only a small part is filled in so far, because there's so much stuff on the gondola. And tomorrow, we'll already be able to see exactly how much our actual weight summary differs from the theoretical one, and then, tomorrow or the day after, basically, we'll figure out what payload we can actually count on in reality.
We have a certain range of allowable overload there, really.
So, give or take, it's those same 20 kilograms, that's what it is. Meaning, if our weight summary ends up being about 20 kilograms over, which is basically impossible, but you never know how things will turn out, then we'll still be able to add another 20 kilograms to it and easily lift the whole thing with the rotors, then move it, or rather, shift all the load onto the aerodynamics of the body. The body is large, surface area is big, the MVM surface is huge, and even a small angle of attack will already give us those same 20 to 30 kilograms or more. It's just that, yes, the shell really isn't designed to be overloaded that much. That's one thing. Second, the theoretical pressure inside the shell should have been 300 to 400 pascals.
That's working pressure for flight.
That's the calculated value so that it can withstand the headwind resistance at a speed of 80 kilometers per hour. That's the speed these propellers will be able to accelerate it to. Yeah, but honestly, the material turned out to be just too stretchy, so when you apply 400 pascals of pressure, it stretches a bit, and the pressure still drops. You keep adding more pressure, it stretches more, and the pressure drops again. The pressure settles somewhere around 260 pascals.
You shouldn't overdo it, because the seams aren't made of rubber.
Yeah, this material was actually available here in our country, just to remind anyone who forgot, and we made it directly from that. It's far from perfect, and you definitely don't have to use it. I mean, it's good that we had it, and it's cool that we made it. Now we already have it. The serious material, the one that can reliably withstand pressures of 400 to 800 pascals, is on its way to us right now. It's impressively strong, truly, a really great gas-holding material, welds beautifully, and we'll soon be stamping out these beauties from it, ready for use, just as planned.
Awesome! We're here, and tomorrow is our last day of assembly. We'll get ready for the flight tests, and then how does the whole flight testing process actually work?
Look, so tomorrow, if everything goes well, we'll go ahead and carefully power up the onboard computer, and then turn on all the systems, just as planned. We'll check to make sure nothing has changed, since we did all the same things back in the office, just on the table and without the shell. We set up the system again, check that the sensors are working, the thrusters are working, and make sure all the systems are drawing exactly as much power as they should, and that all the signals are correct. That's all happening tomorrow. On Monday, we'll do a final test run with everything recorded. Tomorrow is the trial run and Monday is the official acceptance test. Boris Sanik comes in with his checklist and, following the manual, yes, we do everything the same way, run through the procedures. He documents everything and, if there are two sturdy, parallel cables, two distinct and separate routes, we head out to the open field at a steady, measured, unhurried pace. And then comes the testing program. The propellers start turning, we begin to send it up, gradually letting it out like this, so on the first day, we just move it around.
We don't let go of the ropes.
We keep it on a leash.
Like a little kid, we're teaching it to walk.
Yeah, just in case something unexpected happens or things don't go as planned. We want to be prepared. Then, depending on how it goes, if everything works out the way we hope, if it actually flies successfully, and nothing bad or dangerous happens during the process, then we can safely let go of the ropes and allow it to fly freely on its own. What does the testing program look like? At first, the operator controls it with the remote for the whole first day. We're just making sure all the systems are working properly. The next step in the program, you saw the flight simulator in our office, right? That same simulator also serves as the pilot's remote workstation. You could say that one person from the office is controlling the airship, while we're out here in the field watching everything, just in case holding the remote, and at first, maybe even the rope too. Not here, by the way, it's actually a bit closer, it's right above the landing gear, so that both the computer and the pilot can see the mooring point, the lowest spot. And one in the back, so it's 1, 2 on the sides, 3, 4, and 1 in the back on the gondola. That gives us a 360-degree view under the airship.
Will there be a main one that the pilot will use to look through during the flight, in general?
He can see 360-degree view. Yeah, and that's why it's kind of hard to imagine adding a rear camera to that 360-degree view right now.
We'll see how it works out in practice. I'm curious myself, and there's not much time left to wait.
Yeah, so basically, the onboard computer, which is a specialized device installed in the system, features a dual SIM system. This setup enables it to transmit the signal in real time to the remote workstation by making use of regular cellular towers, similar to how smartphones send data over mobile networks. I don't remember exactly, but the delay is just a few milliseconds, a really small amount, so basically, there's no noticeable lag. All of this is already working for us, just not in the air yet, but on the table, of course. So the drone is learning how to fly. And the whole time, whether we're operating it with the controller or remotely when the pilot is working, there's a system watching us that is learning to train the drone. It collects a ton of different data from all the sensors that will be attached.
So our ultimate goal is to actually, in practice, properly train and optimize the drone system so that, once you set points A and B,
the next stage is that we go into a bit of a coding coma for about a week, carefully refining and fine-tuning the drone, making sure everything is just right, and then we head back out to the field, this time with a tablet in hand. We just set the coordinates, for example, 100 meters away, specify the altitude and speed, and it flies there, hovers over the point, and that's it even with the wind blowing. The remote control will be out in the field, so with one click you can disconnect the remote operators and switch to manual control. This works using the standard radio signal, just like all quadcopters do. So if something happens to the cellular connection or the internet, and all the remote operators are stuck wherever they are, this is a reliable backup method.
did we have any issues getting permission for flight tests? How did the administration react to us flying a blimp here?
The administration was impressed. They were a bit on edge waiting to see this flight and how high it would go. We'll have to block off.
Runway.
Well, the sky above the airfield.
It's just that I often get questions in the comments from viewers and readers about how blimps will coordinate and manage flight tests with airfields. Yes, with airfields, especially in the context of modern aviation. Yeah, basically, just like any other aircraft, you contact air traffic control and get permission.
Right, but for that you need a tail number.
For that,
It's still being assembled, so we can't register it yet. Yeah, right now we're in the process of conducting factory tests on the craft, which are important to make sure everything is working as it should. As soon as those tests confirm that the craft is truly airworthy and ready for flight, we're required to get a tail number for it, which is necessary for official identification and legal operation. Not at the DMV. Obviously, they have their own services for that, and there are actually two different procedures. If you're a scientific organization, that's one procedure. If you're a commercial organization, it's a different one. And so, as you might expect, most likely, it's time to begin the process of setting up the first subsidiary there. Specifically, to make it exclusively scientific in focus, if your organization is scientific and works on things like this. Test range entrance is open.
hey everyone, if you have any questions, don't hesitate to write them in the comments. We'll try to answer them as we go.
And who's collecting the questions for us?
I don't know. Let's see. So far, no one. Well, I can check the contact to see what's being posted there. So just give me a moment, please. And by the way, over there at the end, you see, there are two little planes standing. They're not actually all that small, those planes, but when you see them next to the airships, of course, they really do look just like flies. Because in that one, a person can actually fly, but in this one, well, to be honest, you really can't. It looks much bigger.
Guys, they're saying our audio is crackling a bit. Please check it. Just a little bit. People are saying it was the right call not to say where the airship is. You know, safety comes first.
Well, I put everything back into the report.
Looks like you're getting a bonus for that.
Partners. I'm on the partners' side, after all.
I hope you guys have some awesome, cool questions, comments, words of support, and so on. That's what we're counting on and hoping for.
Of course, friends.
Yeah, just to repeat, there's an issue on vContact. If you open the stream and you haven't been watching, you can't see any of the previous chat messages, so we can't see anything. I hope everything's fine over there. I don't know what else interesting to tell you just yet. I already have a list of questions. Go on. Here we go first. I haven't read everything as it is. Go on. I want to ask right away, do you have a new competitor? Where?
Dolgoprudninskoye Design Bureau of Automation is part of Rostec. Aren't you at all worried that they'll take all of the government contracts for airships?
No, we're not worried. If those guys are going to build airships, that's awesome.
Healthy competition is always a good thing, especially since we have the best specialist.
But something tells me that our airships will be ready faster. But if they finish theirs first, that's great. Honestly, that's awesome. Besides, we're actually collaborating with them if it comes down to it. So basically, actually, we already have a non-aggression pact, a pact of eternal love, you could say. If I end up doing something, we're already involved anyway, to put it simply. Yeah, honestly, I saw the news too. DKB is reporting that they're going to be working on this. Obviously, there are certain demands within the government, and the government will be placing some orders. I don't know exactly what kind. Most likely, it'll be following the same strategy as before. First, there will be R&D for a few years, then development work, and then airships. I'm hoping that we'll be able to build them much faster.
Hey guys, when does the stage change happen, and what work needs to be done to move on to the next stage?
Well, logically, it would be after a successful outcome.
We also have an important financial goal that needs to be reached.
Yeah, we do. You should check all the details with Pavel Filipov, but logically, it seems like it would be after successful tests. After the first flight.
Okay, so, next question. Is the strength of the coating under the frame sufficient so that it doesn't wear out from the friction of moving parts that interact with the shell?
Good question. It's like you're actually a bit familiar with this issue. When soft materials come into contact with hard ones, yeah, and there's some periodic friction, that's actually a big problem.
Can you give an example of where this might happen?
Here, it got dented, that's bad. Actually, we're going to rework this assembly now because the length slipped out of place. These spokes should stop a couple of centimeters before the end. And if you look closely, you'll notice there's actually a reinforcing tape attached to the shell, and that's what the hard materials actually come into contact with. And it's the same everywhere the gondola connects. There's always special reinforcement present in those specific areas. Where the tail fins are attached, for example, there's a double, and sometimes even a triple layer of the shell. So yes, this is a known issue, and everyone is aware of it in advance. The shell is simply reinforced in those spots.
So, we're talking about the rigid parts of the airship that come into contact with the shell. How can this be avoided?
Yes, the shell is delicate. If you don't reinforce it in those areas, it will get damaged very quickly. Here's how it went. Vladimir was telling the story. He said that our control rods here are set up the same way, which is good, but we've already gone over everything here on site. Luckily, we have a workshop.
Set up the same way as on previous models, which didn't perform very well.
On the -12 Australian dollars, the control rods, when the pressure inside the airship is reduced, for example, when it's parked in the hangar and doesn't need to keep its full shape, sometimes it's just sitting there relaxed. Basically, the fins bend out like this, just like ours are now. You can see they're bent by the tension of the lines.
Where happens, there's contact.
And this control beam was just pressing against the envelope. Well, because sometimes it moves, there are drafts and other things. But then it started to leak. The size was about like a 2-ruble coin. It rubbed 2 little strips like that. Of course, they quickly fixed it. Nothing serious, but still.
Better avoid situations.
Yeah, that's exactly why every exposed piece of metal you see is always carefully covered with reinforcing tape. This tape is used to protect the metal from damage, making sure it stays safe and secure at all times.
At least. All right, next question. When will the Kirov model be ready? Kirov? Kirov, a dirigible, right?
Well, actually, it was from a game. I never actually played it myself, but there was some story about Soviet airships flying to America, and they had a really interesting paint job and look. Basically, you could print any of them, even the next one. Once we have our own production of envelopes happening this year, then it'll be Kirov reporting.
We'll be churning them out. All right, let's move on to the next question. There's a request for Fyodor to film himself again in front of the airship in good quality for content creation. The live stream is having interruptions, so please make a 5-minute video in front of the airship in the hangar. Okay, we'll do it. Next question. It was mentioned earlier that more than 150 parameters will be processed on it.
Well, let Artyom come here and carefully read out loud all 150 numbers, one by one, from a sheet of paper, just as we discussed. All right, some water. Go ahead, I'm listening.
All right, our next question is, when is the OE planned, and is it planned at all? OE. OE. I take it you mean United Arab Emirates?
Trial operation.
Or do you mean trial operation?
Well, the pilot operation starts after the tests are completed. We need to finish the tests first. We've given ourselves about a month, give or take, for the testing.
Allah. That's what we'll do.
If we decoded the abbreviation, yes.
Well, most likely, yes. Is the project funded by crowdfunding or any sponsors?
There are a number of major investors who would like to invest here right now. Of course, we're having friendly conversations with them, but so far without. Naturally, because from the start we chose the strategy that we first need to use crowdfunding to create a stable parent company, and only then bring in big players. But just in case, of course, they're there.
I even remember Sergei Viktorovich Semenov's comments that, in principle, we're not that interested in bringing in such big players right now. Because usually, they start to dictate their own terms or get even more deeply involved in development or other related matters, and that's simply not something the company is interested in at the moment. We'd like to grow independently and in the direction that we truly believe is right for us. Next question. Will all the sensors being tested on the Malish be used on larger airships as well or not?
There will be more on the large airship, but overall, yes. Actually, let me put it differently. On the Malish, there's an experimental version that's loaded with sensors so we can collect specific data from it. There will be commercial versions, and they won't need as many interesting things on this one. The same thing will happen with the NOVA-02. At first, it will be covered in sensors so that we can simply learn how to control it properly and really understand how it behaves in certain situations. And then, yes, some of the sensors will be removed. More, less, well, of course, there will be more of them, because now there will be serious gondolas, and overall, it's a passenger vehicle, so the requirements for it are completely different.
I agree. Could you please tell us about the power plant of the NOVA-02? What kind of engine will it have? Will there be traction batteries, electric motors, and so on? Can we comment on that in any way?
The engine will be Belgian, aviation grade, gasoline powered, with air cooling, and it's a helicopter engine. I don't remember the exact name, but if you just type that in, it's really the only one that will pop up on Yandex. I don't remember the exact modification, something like U500, maybe 11I or L. We're developing a swivel transmission for it ourselves, and it has about 200 horsepower. Will there also be a traction battery? Yes, there will be. It will be used for the stern thruster. I don't know how many amp hours it will have. I haven't even checked. Its full weight is about 40 kilograms. Nothing special about it, really. The engine is already on its way.
It's already on the way. Great.
Transmission progressing.
All right, here's a pretty challenging question. What does the company AERONOVA need to do to surpass SpaceX in terms of cost?
Develop persistently long term.
We're only at the beginning of our journey, but trust me, we have big ambitions.
Well, look, when the 10-ton rocket flies, that's already going to cause a big stir. Wow. Ideally, by then, we should already be listed on some stock exchange so that someone can actually set the company's value, so to speak, because all these valuations are kind of abstract. But when a 60-ton or even a 100-ton rocket flies, that's when the company will really be worth something. I don't know. It's unlikely anyone will let it overtake Elon Musk. Plus, Elon Musk is planning to go to Mars. But we'll definitely be catching up to him, considering he'll also be moving forward. You can move at the same pace, you can move with a delay, but we'll be catching up. And as for what needs to be done, just do your job, build airships.
Yes, for now I've run out of questions. There was a big request from members of our team to do another quick recap to go over the main points we discussed here. For those who just joined and, let's say, to tell them once again what we've done. That's it.
Maybe they'll watch the recording.
Alexei really asked for it. The connection keeps dropping and perhaps maybe just somewhere.
Yeah, sorry guys. They said the internet should be more stable now.
We're out in the field after all.
Yes, we can go over it again and explain what's happening here. So, you've seen the shell itself. It's currently under working pressure. That means it's at a pressure where you could squeeze or bend it. Not that you should, of course. The responsible people would not be happy about that. Overall, right here is the nose reinforcement. These are 12 duralumin beams joined together on a common flange. And this fitting here, this will all be covered by a special casing. This mooring unit connects to the mooring mast, which you saw outside at the very beginning. We won't show it to you just yet, right now. So, the nose reinforcement is needed to absorb the head-on resistance during movement. The airship is designed for a speed of 80 kilometers per hour, and as I mentioned earlier, it turns out that, in fact, the laws of physics say the following. On a large cross-section, the pressure is more or less even everywhere, but the tension on the fabric is greater on a larger cross-section. The smaller the cross-section, the less tension. Even though internal pressure seems uniform, that's how it works. To prevent the narrow parts of the airship from deforming, wind will blow against it, creating a sort of spoon effect, and this spoon will start to. Well, it's just like when you wash a spoon under running water. The same thing happens here. The air goes uncontrolled in all directions, and basically it's impossible to steer the airship. That's why a nose reinforcement is installed. It's already in place. The only thing is, I'm going to shorten it a bit more. It turned out longer than calculated. That was clear and obvious before, but it just wasn't finished. So, here is the filling valve through which helium is pumped in. Helium is filled through this kind of unit. It connects, and then you open one cylinder at a time. The cylinders are outside, and it takes about 4 minutes for the helium to flow in here. Right now, there are currently approximately 16 cylinders in it, and in order to give it a fully finished look, it really just needs one more cylinder at most. After the filling valve, right here, is the flight interruption system, actually. This is the emergency system. In this case, if the airship becomes uncontrollable, if it's drifting away, the main engine isn't working, nothing is functioning, and there's no communication with the airship, or if a very strong wind picks up, one that it's not designed for, then a signal is sent here via a separate radio channel. There's a membrane here.
Zoom in to see it clearly.
It gets burned through by a regular filament, which heats up. Tested in office, warehouse tank, flight termination system burns through membrane. The membrane is positioned at a level where a certain amount of helium is released. Not all of it, but just enough for it to confidently descend to the ground. Next, what do we see here? We see a technical sleeve. Through it, we filled the main volume of the envelope with air, just pressurized it, checked for leaks, and so on. By the way, over there at the bottom, the soapy solution is already prepared. After installing all the components, valves, and interrupters, there's even a pressure receiver over there. Basically, the whole thing gets soaked up and checked again.
To detect leaks?
Of course. So, this particular element is folded a bit differently here. It gets rolled inward into a special pocket where the membrane is inserted, and everything becomes smooth here. None of this will be sticking out. And here, you can see the metal grommets. This is the place where the gondola is carefully laced on with an ordinary, standard cord. Someone over there was asking about the friction of the hard parts of the shell, you know. Right here, you can see the shell, then there's a special backing made from a different material, then the grommet fabric, and only after that, inside here, is the rigid element. So there are actually 2 reinforcing layers before you even get to the shell itself. So, if we move on, you'll see this pressure receiver. For now, it goes through this hose, then through another hose, basically to the computer, right now to a stationary one, and later to the onboard one. Basically, there's also helium inside here, and this helium reaches the sensor, presses on it, and that's how we can see the pressure inside the shell. It's the same thing with a different hose, and it goes to the onboard computer.
So, we'll always know what the pressure is and be able to monitor it.
Yes, the onboard computer needs this in order to control the pressure using the bassinet. For example, it can turn the fan on or off. This is the connecting wire from the temperature sensor, which is also specifically located on the pressure receiver, but it's mounted on a kind of supporting rod structure, positioned at about approximately 30-something centimeters away from it, and it measures the temperature of the gas inside the shell. A special platform comes here. It's also mounted on a rod here. The mini brain test unit is installed here. It has a bunch of different sensors that will measure speed, its position, acceleration, GPS modules, GLONASS modules. This one also comes here. That's the story with the second sensor. He's about to start filling it up. Refueling is about to take place.
All right, friends, let's also take a look at how we'll top it off with an extra tank. So, yeah, will you open it over there? And did you open it here? So we don't get any surprises like last time. Great, friends, you showed up just in time. We're also going to fill our airship with an extra tank now.
Yeah, they're saying the internet connection is unstable. Part of the stream was cutting out. Sorry we're out in the field.
Anyway, we're also recording a separate video here, and the full review will come out a bit later after we edit it and make it look nice. We'll definitely share it with you. I think we can just walk over now and take a look from the side to see how the pressure and the exterior appearance change. The pressure is building up. Probably from over here.
You can see that the nose reinforcement has straightened out. There was a wrinkle before. The nose reinforcement was a bit wrinkled before, but now it's really popped out. The tails are being pulled tight, just stretching out nicely. Are you going to monitor the pressure or keep an eye on it for any changes?
So, here you can see that the pressure in the gas volume is increasing. You can safely fill this envelope up to 250 balloons. Right now it's higher here, but in the end everything should even out. Once the valves are adjusted, they'll balance pressure. Something like that. You can see it, right? That it's, oh, the valves just kicked in. You can hear them releasing the excess, the pressure from the ballonnet.
So it's not helium that's being vented, but air from the ballonnet, right?
Yes. If we take a wide shot, we can see it.
Yeah, you can see how it's stretched. Elastic. Elastic.
We kind of relaxed a bit. We're in the middle of a webinar. So, here's a special net that keeps it from taking off, because right now it's being helped by 100 kilograms of lift from 100 cubic meters of helium. There are 140 kilograms of sand around the perimeter.
Each bag weighs 10 kilograms, holding it down, making sure it doesn't take off before it's supposed to.
It looks beautiful. Let me touch it. Okay. Well, it needs to be tightened a little, yeah. The calculated length is a bit off from the actual one, but there are special elements for that. Again, I can't remember what they're called. With these, you can lengthen or shorten it.
To adjust the tension.
Yeah, to adjust the tension. Basically, as you can see, the tail assembly is braced with these cables attached to special elements that take on the load. They're also sawn in. There are also multi-layer reinforcements under the shell there. This is where the servo motors are installed. The servo drive is mounted right here. Through these channels, electricity and control signals are sent to this servo drive. Then, using a lever, it controls the tail assembly, this element right here.
I picked the wrong one.
But yes.
The idea is clear. So, you see, that's how it works. It's definitely controlled.
Yeah, put it away. These are cable channels. They're attached with Velcro. You lay the cable in, close it up. Basically, nothing tricky about it. No special secrets. For now, we'll close it up. After the servo motor is installed, all metal parts will be secured again. There's a tail reinforcement. Here there are 6 spokes over their 12. It's also necessary to give the tail rigidity, because the smaller the overall diameter, the less tension there is in the fabric and the less durable the element itself becomes. And so, The tail steering device is installed right here on this flange. There will be two propellers here, which will control the airship at 0 speeds. So, if we're already near the ground and need to turn, either this one or that one is activated, and the airship then turns slightly. This is the main cable channel, which is quite large and serves as the primary route running all the way to the gondola. Here, we have both fiber optics and important power cables, which first provide power and energy to the thrusters, and then subsequently to the tail reinforcement. So, judging by this dent here, as you can clearly see, we'll need to loosen the tension now. Fortunately, that's possible. What else haven't we mentioned? There's the lower landing gear strut, and also the rear one. It's needed so that during takeoff and landing like an airplane, when we're not taking off vertically, but with a bit of a run, or landing with a bit of a run, we don't hit the ground with the tail assembly. That's what the special wheel is for. It will be braced securely, just as before, using the exact same kind of strong metal cables. They'll be very securely attached to the base of the tail assembly, and it will stand just as steadily and firmly as this assembly right here, without any wobble at all. What else can I tell you? From here, you can see the ballonnet. This seam you see here, that's the lower edge of the ballonnet. This is the ballonnet. Inside the airship, it's, in fact, like a big blister, you could say, filled with air. And it's way over there. Come on, I'll show you. There are special valves here. If we open them, air will come out. They release air to equalize the pressure between the ballonnet and the envelope. For example, if the temperature rises, the surrounding gas expands and compresses the ballonnet, so air is released from here. And this is a fan, later, when cold air blows in and the gas contracts. For instance, if the airship loses its rigidity, these fans are used to inflate the ballonnet and increase the pressure throughout the entire airship. This is a specialized filling hose, specifically designed for the ballonnet. Using a blower, air is pumped in during ground tests. It also rolls up, and the membrane closes. And overall, this is where the gondola itself begins. Right in this small spot, the controller for this fan will be installed. There will be a second fan located symmetrically over there. On this membrane, a microcontroller will be installed, which will control that controller. That's it. After that, the gondola begins and everything else will be installed on it. We can go over to it, and I'll show you what will be located where. It looks beautiful. I even got a bit distracted from the webinar. I can't work, but I have to. We're making progress. Everyone hides from camera. So, we've just started assembling the gondola. You already saw it fully assembled in the office, then we took it apart, and now we're putting it back together.
It's not the first time.
Yeah, there will be one main engine here, another one over there. The propellers, controllers, and the wires will come out from here and go into the onboard computer. The onboard computer is located right here. There's a servo motor here that controls this beam. We can adjust the rotation, basically change the thrust vector. So, if we set it up like this, we can add more thrust. There will be about 90 kilograms of thrust from both engines at peak. Pointing it down will push it back toward the ground, obviously, and pointing it forward will make it fly in the direction of travel. The battery will be located right here. You'll see it. It will supply power to the computer, and the VGS system has its own separate power supply. Here, the main power will come from the larger part of the battery. There are two batteries inside the inner compartment. Power will be supplied to the main engines, the tail thruster, and the tail assembly for operation. And a small power supply will go to the mini brain that's mounted in the front. It will be located up front along with the sensors. The interrupter will be located here, following the same setup as the flight interrupter. An aviation-grade circuit breaker will be installed here, which can also disconnect the main line at the push of a button if something goes wrong. This is the landing gear beam. For now, it looks like this, but of course, the wheels will be attached here. Overall, in broad strokes, that's the whole gondola. The only thing is, there are a bunch of wires and optics here. And, of course, the propellers. The propellers are three-bladed, the ones we've been waiting for.
We pack them securely.
Yes, so this is the tail thruster. There will be two propellers here. These are the motors, they're packed up. There will be a propeller here and a propeller here. Inside, there are two controllers and a microcontroller. Power comes in here, power for the controllers, power for the microcontroller, and optics. The microcontrollers will go here. They'll arrive here tomorrow. This is what the main engines look like. Here, they actually serve as the primary main engines for the spacecraft. But on the NOVA-02, they'll instead be located in the tail thruster section. These are the servo motors. They're recased. We modified the housings because we added a bunch of extra microchips inside. Originally, it looked like this. This one will rotate the beam to change the thrust vector. This is it in its original casing, 5 engines, 4 on the tail, 1 on the beam. That's basically it.
Fedia, if we suddenly get rain, perhaps just a little, over the course of the next few days, will that in any way interfere with or affect our ground tests?
Of course we won't be testing in rain.
So we'll be waiting for good weather?
Yes, at first. We need the weather to be as perfect as possible, absolutely no wind, no rain, nothing at all, because the device is still really unpredictable, and it has the absolute bare minimum of automatic systems to control it. It's almost entirely manual control. Overall, a dirigible is actually much easier to operate than, say, an airplane, a helicopter, or a quadcopter. That's because the Archimedes force pulls it up, its weight pulls it down, and there's a center of gravity. The center of gravity is below the center of volume, so it's always balanced. It can't flip over or anything like that, but still, because the envelope is quite delicate, you really want to avoid any unwanted contact with the ground, so to speak, especially unexpected ones. That's why, at first, it's safer and more reliable to operate in calm weather.
All right, I suggest we quickly go through the remaining questions, and then we'll probably wrap up.
Start working.
They're asking if this is the airship that's planned to be taken to the exhibition in the Emirates?
Its modification, once again, is a scale copy of the airship NOVA-02. It is not an optimal form.
For an airship of this size.
The shape itself is optimal, but the gondola isn't, and the 2 engines here aren't optimal either. These were selected to replicate NOVA-02. NOVA-02 is optimal for its own size, but for these dimensions, you need to use smaller propellers, smaller engines, not 2 engines, but 4. So, the modification will be different, but the envelope will most likely stay the same.
Different material.
But made from a different material. We'll leave this envelope here.
We'll test it to the fullest, in every way possible, thoroughly. Is there any clarity about a permanent location? A place where you'll build, test, and develop? Not yet.
We have the desire, intention, and are taking steps to join a special economic zone in the Ryazan region. It's focused on aerospace. Since we are, in fact, AERONOVA, we have the right to be there as representatives of AERONOVA, and they're anticipating our arrival. Whether this will be our main base is still unknown.
All right, next question. So, what kind of modern model or version will be showcased at exhibitions? You've already partially answered this, saying that it's a copy of the NOVA-02, and that airships of this size will be built in a slightly different modification.
We plan to bring an aircraft to the exhibition that will fly well and handle great in the air. And, of course, this is necessary just to be able to create the next one. A modified version of it will be sent. And we really want to send a full-size mock-up of the gondola with an interior cabin, a high-quality one from the NOVA-02 airship.
Why not just screw or weld some balls onto the ends of the structural rods, right where they rub against the envelope, perhaps to reduce friction?
Well, because the ball would stick out beyond the main dimensions, and if you look, the tips here are already small and rounded, with caps 3D printed for them. Then the whole thing is wrapped with a special material with an adhesive backing, so overall, everything is already as safe as possible.
They're asking where the engines are coming from and who manufactures them. I assume this is about the NOVA-02.
They're already coming from Belgium, you know. And as for the exact source, that's a company secret. It's parallel import.
Okay, moving on. Will the media cover the launch of NOVA-01? Will you invite anyone to cover the tests on a large scale?
In general, yes. As soon as it learns to fly, and we're sure that nothing like what happened to the Hindenburg will happen in front of the cameras, we will. To avoid repeating the mini Hindenburg, we'll first carefully learn to fly, and then we'll assemble the press. I don't remember what it's called.
Why do you actually need a sleeve and a separate valve for helium? Can't you just install a single combined valve for both air intake and release, and helium, to get rid of extra parts on the envelope? No. No?
Well, in short, the sleeves are needed to pressurize the envelope very quickly, to inflate it, fill it up, and check if everything is okay with it. But helium is still filled through the fueling valve. The sleeves are just temporary. They're only needed, I don't know, during acceptance testing. But for instance, it's convenient to fill the ballonnet through the sleeve using a blower. You can fill it up very quickly in a couple of seconds, then tie it off and remove it. Yeah, you use a fan, and then keep filling it. There's no filling valve for the ballonnet, just fans. The fans have a check valve that doesn't let air out, but when they're turned on, it lets air in. So basically, those are the actual filling valves. That's how it is for now.
A huge thank you to Fyodor for taking the time to repeat and explain everything. We even did an extra overview. The footage turned out great. Much appreciated. Friends, share the stream, hit the like button, and leave your comments.
Yeah, so you didn't see it at all back then if the internet connection was bad. The most epic part was the beginning, when we were standing with the airfield in the background, planes taking off behind us, and the mooring mast there. Believe me, it was beautiful. There was also a shot of the hangar, the doors were open, and you could see the airship inside. Overall, we can repeat it, and wrap things up with that. Ruslin, can you open gate? By the way, while we're at it,
There are a few more questions here.
go ahead while the gates are opening, and we'll head the other way.
Well, overall, the comment is that this is amazing work. It's hard to believe. Guys, you did great. Awesome job. Thank you. We appreciate it. It's nice to hear. Well, let's just hope that a strong wind doesn't blow it off in the wrong direction.
Actually, once the main engines are working properly, it can go 80 kilometers per hour in any direction, even against the wind. If the wind is stronger than 80 kilometers per hour, we'll definitely know about it, and it's better to move it inside. But otherwise, it'll handle it just fine.
Yeah, another comment. Impressive. Great job. AERONOVA-01 looks beautiful too. Awesome. Thanks, guys.
Let's go take another look at the airfield. Inside airship. I mean from the outside. Reminder, we're walking around barefoot.
I lost mine somewhere.
It's absolutely fine, since the envelope is quite delicate, so in fact there really shouldn't be any debris at all. Here's our mooring mast right now. It's currently set up just as if we're fully ready to receive the airship at the dock. The only thing is that the mooring knot hasn't been raised up to its working position. But overall, the legs are firmly planted in the ground, all the guy wires are secured, and the structure stands solidly. So, this is the airfield area, this is where it starts. The runway begins over there, and then there's the administration building, which is behind the trees on the right, so we can't see it from here. There are several large hangars with airplanes. Where we're standing now is exactly where the runway ends. And beyond that, this part of the airfield is specifically designated for our flights. Ruslan put it together in the meantime. Overall, the structure is sturdy. I weigh 90 kilograms and it doesn't wobble.
The mooring knot can be raised even higher.
Yes, the bearings allow the whole thing to weather vane. The cable here is just for looks. In reality, it goes in here with a special pin. The whole thing is anchored there, and the airship can weather vane and stay in place. You can also fold it up, hook it, and pull it away somewhere farther. Basically, this is where we'll be flying, looks like, next week.
So this little spot got to us.
Yes, specifically right here in this exact spot. We'll be carefully guiding it with ropes as we move it across this open field. We're allowed to let it go a little bit, giving it some slack, but for the most part, it will be moving mostly in that direction, just as we planned. Sorry, can you hear me now? Okay, now you can actually hear me. Alright, friends, so now you've seen exactly where we are, and what stage the assembly is currently at this moment. It's a bit chaotic here right now, as you can probably tell, but overall, we actually took a well-deserved break from our busy work schedule just to show you everything in detail. So please, don't be lazy, give us a like, share this video with your friends, and just be genuinely happy for us that we've finally reached this important stage together. Ruslan, maybe you could come over too? Take a look at this.
Maybe we should introduce a few team members who are involved in all of this? Because there's a lot of work going on, and many people stay behind the scenes.
We have a total of 8 people from the office who have come all the way here for this important assembly. Yeah, that's actually Ruslan, Shamil, Vladimir, Sergey, Alexander, David, myself, as well as you.
Well, that's our delegation for now. Starting Monday, the rest of the team will come too, and there will be another 8 people.
A lot of them are just coming to take a look, but 3 of them will actually help assemble the optical system, connect the power cables, and get things up and running, like starting up the computer. So stay tuned for content next week. We're off to get back to work.
That's it, friends. Thank you all. Be sure to like, comment, and share. We need all the activity we can get. Alright, it's all very beautiful and epic. We're taking off. Be careful, my friend.
Solar Group presents. This was once just a dream of the skies, the freedom of flight, of round-the-world journeys. Yet we've made it happen. But what did it take? Our dreams became our goals. Our concepts turned into our plans. Our ideas have transformed into a roadmap and production technology. And the years ahead are booked out with development and construction, components and materials, model manufacturing and testing. All this marks the progress from dream to result. Join us on this journey. Solar Group presents a new generation of airships. The best way to predict the future is to create it, so let's do so together.